Hi, I'm Jeff Wulick, and thanks for tuning into my presentation. I'm a retired college professor, and like most of you, I'm a weather geek, and have been since about 10 years old when I got my first weather station. That's another story. Anyway, I'm a member of the Coco Ross Weather Network, the Davis Instrument WeatherLink Network, AMS WeatherBand, and the Mountain Rain or Snow Project, which we'll get into in more detail in this presentation. But before I get into it, a full disclosure. I'm not a scientist. I wasn't involved with any of the science in this project. I'm simply one of the observers with a keen interest in this project. And the content of this presentation is aggregated from several studies and reports which are cited at the end of this presentation. All right, let's get started. Did you know that snow can fall at temperatures above freezing? Well, as we'll see, that depends. This brings us to the question of what is falling from the sky right now. In 2019, Monica Arienzo, Megan Collins, and Keith Jennings of the Desert Research Institute in Reno and Linker Technologies in Boulder, they launched a project called Tahoe Rain or Snow. This project was designed to answer that question using citizen science observers to collect boots on the ground observations of precipitation phase. Was it rain, snow, or a mix that was falling from the sky at any given moment during a storm? The study area was located in the Tahoe Basin and the Truckee Meadows areas, which includes Lake Tahoe in the Sierra Nevada and the urban areas of Reno, Sparks, and Carson City in western Nevada. This area is popular for winter recreation and is also a critical part of the regional water resources system. The Lake Tahoe region is characterized by Lake Tahoe, at 6,200 feet, and the surrounding mountain peaks at around 10,800 feet. This region's climate is characterized by a wet season from November to April and a dry season from May to October. Most of the wet season precipitation falls as snow. The Truckee Meadows region, at about 4,200 feet elevation, is located on the eastern side of the Sierra Nevada. This region has a similar seasonal climate pattern with overall less precipitation and typically more rain than snow. In these regions, and of course in much of the western U.S., households, agriculture, and industry all rely on mountain snowmelt for their water supply. In the study region, a significant amount of annual precipitation falls near freezing. And this is important because at these temperatures, weather forecasts, land surface models, and satellites all have difficulty correctly predicting and observing precipitation phase. This makes visual observations the most accurate approach to getting data. The project's premise was straightforward. Engage citizen scientists to collect ground-based observations of precipitation phase during storms to get a better idea of rain and snow data. It was time to set up the parameters of the project. It turns out that humidity plays a big part in this rain or snow question. Areas with high humidity, such as the west side of the Cascade Range in Washington, snow transitions to rain at around 32 to 34 degrees. In areas with lower humidity, such as the east side of the Sierra Nevada, snow can fall at even warmer temperatures. Normally, weather station observations of air temperature and precipitation phase are used to predict whether it's raining, snowing, or a mix. Due to a limited number of these stations, especially in the mountains, computer weather and hydrologic models are typically used to fill in the gaps. Even ground-based radars and satellites struggle to predict precipitation phase at temperatures near freezing. These issues are particularly important in the Sierra Nevada, where a significant proportion of winter precipitation falls near freezing. Using the wrong rain-snow temperature threshold results in biases in snow water equivalent, snow water depth, and snow duration. So basically, if you increase the monitoring, what is falling, to validate the modeling of rain or snow, this would significantly improve the prediction of precipitation that accumulates in mountain snowpacks, and conversely, the water that also runs off. How do we do this? This citizen science project required user-submitted data that can only be done with accurate observations of weather at the surface. Obviously, boots on the ground are needed to report this data, so recruitment was a critical component of this project. The recruitment strategy included outreach to winter weather and outdoor enthusiasts, combined with an amplification through social media and the engagement of regional weather groups. Once signed up, we citizen scientists submitted observations of precipitation phase using an existing mobile app called Citizen Science Tahoe. A simple survey developed by the science team called Tahoe Rain or Snow was hosted on that app. Using the app, we reported the current precipitation phase. Was it rain, snow, or mixed that was falling from the sky at that moment? Our observations were automatically geotagged and timestamped, which provided critical information on where and when the report took place. Additionally, a text message blast was also sent to all observers prior to the storm event. This seemed to be a very effective tool to keep everyone engaged. Between January and May 2021, almost 200 citizen scientists made over 1,000 observations of rain, snow, and mixed precipitation. This image shows the location of every observation point throughout the study. In the publication, you can click on any data point and review all of the observations from that point. So now you ask, what was the point of all of this? This brings us to the goal of the Tahoe Rain or Snow project. The goal is to work toward reducing inaccuracies in determining precipitation type by estimating the temperature of the rain-snow boundary, which is used in weather forecasts and hydrologic models. Why is this important? Well, rain and snow have different effects on the land surface. The greatest concern to downstream water users in Nevada and California is the difference between water storage and flooding. Snowpacks act as ideal natural reservoirs. They store water throughout the winter and early spring and then release it as the temperatures warm. This also coincides with the increase in both human and natural demand. Rainfall does not produce the same effect. Instead, it just runs off during precipitation events. Unless you live on the West Coast, you may be unfamiliar with atmospheric rivers, but they are a big deal out here, and atmospheric rivers provide most of the moisture to the West Coast in the winter. Here we see one slamming into the north central California coast. These large rainfall events produce intense amounts of precipitation in a very short period of time that often results in rapid runoff. This can cause flooding, landslides, infrastructure damage, injury, and death. By the same token, the Sierra Nevada mountains can also accumulate precipitous amounts of snow, which contributes significantly to the snowpack. These storms often come in near the freezing point, making it essential that we can accurately predict whether it's rain or snow falling from the sky. So basically, if you get this rain-snow line wrong, you might miss a potentially damaging event or get a wrong estimate of the water equivalent in the mountain snowpack. So what did we learn from all this? Remember the project goal? Reduce inaccuracies in forecasts and models. So the success for the purpose of this study was defined as meeting our goals to recruit and retain citizen scientists and collect a sufficient number of quality data points for precipitation phase analysis. First, none of this would have been possible without boots on the ground. Here we showed that citizen science is a viable approach for collecting high-quality data, especially when a recruitment, engagement, and retention program is implemented. And second, observations show that snow can and does fall at temperatures above freezing. As we can see from this image, even at 5.9 degrees Celsius or 42 degrees Fahrenheit, it is clear that snow is falling. It's heavy and wet, but it's still snow. Note the humidity at 59%. In both the Tahoe and the Truckee Meadows regions, evidence of snow consistently falling at above freezing temperatures was recorded. And importantly, similar air temperature thresholds were also recorded. After analyzing the data, the key question was, what would be the most effective temperature value to partition rain or snow? Remember the hydrologic models? Ground-based observations submitted by the Tahoe Rain or Snow observers showed that a much warmer temperature threshold for splitting precipitation into rain or snow may be more accurate for our mountain region. Therefore, based on these observations, we calculated this crossing point to be 39 degrees Fahrenheit or 4 degrees Celsius. At this temperature, there's an even chance that precipitation will fall as rain, snow, or mixed. But what is a bit of a worry is that this is a markedly warmer temperature than what you would find in most hydrologic and land surface models. So now you're like, snow at 39 degrees. What's the big deal? Well, let's put this into perspective. During the study period, more than 1,000 reports were submitted. Of these 1,000 reports, 570 reports were reported at air temperatures between 32 and 39 degrees Fahrenheit. Of those 572 reports, 410 were snowfall. This means that if a model uses a 32-degree rain-snow temperature threshold, this leads to a misidentification of snow as rain 72% of the time. Okay, of those 410 reports, 317 were between 35 and 39 degrees. So even if we were using this warmer threshold of 35 degrees, this would lead to a misidentification of snow as rain 60% of the time. This means that a significant amount of precipitation that is currently recorded as rain is actually falling as snow. This is a big discrepancy. It affects simulations of the hydrologic cycle, and it may impede our understanding of the climate change influence on snowfall trends, and also how watersheds respond to changes in the snowpack. Ultimately, the data from this project will be used to improve the hydrologic models and satellite and computer model predictions of rain and snow in the Sierras. Because of the success of this project, in 2021, the scientists team received funding to continue and expand this project with an award from NASA. And as a result, this season they will be growing this project, now called Mountain Snow or Rain, into new regions beyond the Sierras, including the Cascades and the Rockies. We're always looking for more reports of rain, snow, and mixed precip. Here's the region contact info. Take a screenshot. So if you live in or near any of these regions, send a text and get involved. It's actually a kind of a fun project. If you're really interested in this subject, these three publications will flesh out what I've covered here. Take a screenshot and check them out. So here are the details. Should you want more information, I'm more than happy to share, or you can contact DRI directly. I live in the foothills of the Sierra Nevada and have spent a good part of my life playing in these mountains. I know I learned a lot about this phenomena during my participation in this project, and I have a much better appreciation for the implication of this information. Thank you for tuning in, and I hope you found this information interesting and informative.